Welcome to Inflammation Nation. My name is Gráinne O'Leary. Inflammation Nation is a podcast from Arthritis Ireland, aimed at increasing awareness and understanding of arthritis and related conditions. Welcome to Inflammation Nation. My name is Gráinne O'Leary, and I'm delighted to be joined today by Professor Luke O'Neill, who is Professor of Biochemistry in the School of Biochemistry and Immunology at Trinity College Dublin. He's also been a very familiar face and a voice on our screens and on our airwaves during the Covid-19 pandemic. Luke, you're very welcome and thanks for joining us today. So I'm going to start maybe back at the beginning of your career. You know, what got you into this whole area of study in the first place?
Well, that's a good question. I began, many years ago now, 1985, can you believe it? Working on Crohn's disease was the first inflammatory disease I got interested in initially, you know. And then I got fascinated by the inflammatory process. And then I went to London to do a PhD and began to work on rheumatoid arthritis. That was the next big disease I worked on.
Are we always interested in science? You know, even if I take you back to
even
before,
further,
further, like when you were...
You're asking me, that's a great question to ask. I talk about that forever. I don't know, you know, in school, it's like many of us in school, a great biology teacher. His name was Fran Mooney, and we always mention him, actually, me and my classmates. He really inspired us to love biology, you see. And then I went to Trinity to do biochemistry because I wanted to learn about the chemical basis of life. But I realised disease was where I was headed always, kind of. You know, I actually applied to do medicine, and I changed my mind in the CIO form, much to my mother's annoyance. And I did science instead. But I always thought science is great. But if you can make discoveries that might be useful, that'd be even better, kind of thing. You know, and that was in the back of my mind for a long time, I suppose.
And why immunology?
Well, it began with Crohn's. When I realised that was an inflammatory disease, which meant the immune system was dysfunctional somehow, you know, and they realised, it could be 80, 90 years ago now, many of these diseases involve the immune system getting sort of crazy and going out of control. And, you know, in the case of Crohn's, it beats up your colon. In rheumatoid, it's your joints. And it looks like it's infected, but it's not. And that got my imagination. I said, to understand those diseases, then you have to understand the immune system. So I began to get more and more interested. And I was in London then. I did lots of immunology as part of my PhD, you see. And at that time, all these discoveries were happening. Cytokines were being discovered at the time, which was a huge breakthrough for immunology. And it became very relevant to rheumatoid as well, of course. So just immunology seemed to me to be a fantastic area scientifically, because it's so complicated, and scientists love solving puzzles, you might say. But equally, then you might find something useful, you know, that could help us understand disease. So that was always part of the motivation.
Well, I think thanks to all of your work in the last 18 months in relation to COVID-19, you know, I think maybe for the first time, there's a greater awareness and understanding of what an immunologist does and the whole field of immunology.
There's so many of us
now,
fantastic.
Isn't there?
We're on the news every night for a while.
Absolutely.
We're gone away now, because the virus is almost
I suppose, what's that been like as an immunologist, you know, during the last 18 months living through a pandemic? Because it certainly has heightened its
it got very intense.
Presence.
I'll tell you that much during those, especially, you know, when COVID was just the most dominant news story, wasn't it, in a way? And then several of us were asked to go on the media and speak about it, and we were always very happy to do it. Some of my great colleagues in Trinity, like Gráinne O'Leary, for example, you know. So we were very happy to do it because we have the knowledge. Why wouldn't we share it with people? And the appetite was vast. And my other big interest for years was science communication. So when COVID came along, they asked me to do more of it, and I just did more of what I was doing before, kind of thing. But you're right, though, the public now know what an antibody is, say, or they've even heard of T cells or antigens. All these words are now kind of in our lexicon, in a sense, aren't they? So for a good reason, because COVID was so devastating, you see. And then, of course, the mission became get out of this damn thing. That meant vaccines and therapies. And as you know, Gráinne, some of the arthritis therapies are using COVID strains.
Yeah, I was going to ask you about that.
That's fascinating. That, yeah. So in other words, I think my lab worked. I'd worked on infectious diseases as well, because septic shock is an example of an inflammatory consequence of infection. So I had a big interest in that for years, you see. So when COVID came along, many labs began to work on COVID, my lab included. We would have had 3 projects on COVID over the last year, you see. So it was easy. Well, it wasn't easy, but we could redeploy our efforts towards COVID, and that was a really important thing for us all to do, really. You know?
And what were some of the learnings from your work, you know, in the last year and a half on COVID?
Well, early on it was very clear that this is an inflammatory disease of the lungs. I mean, obviously the virus goes into your lungs, and if you get sick with this disease, the inflammatory process goes out of control. So, and they began showing things that are in rheumatoid overlap, like IL-6, TNF, macrophages. They're in COVID. And I work on those things. So we began then to apply our knowledge into COVID. And we were specifically, actually, we work on a strange thing called itaconate, which is a natural anti-inflammatory molecule that your body makes to suppress inflammation. And someone else showed that was down in COVID. And then, well, could we replace it? And then we began giving itaconate into model systems for COVID. And now we've had 2 discoveries, hopefully, that might pan out, that this could be a way to treat COVID. And then beyond COVID into other inflammatory diseases. So we've learned a lot about inflammation and airway inflammation in particular from studying COVID, which could be applicable then to other diseases.
Okay. And you talked a few minutes ago about some of the drug therapies that are used, to treat arthritis have also been found to be effective. How did that come about? And can you just tell us a little bit more about those therapies?
Yeah, well, they began measuring stuff in patients. So they would take, and we in my lab now, we would be getting patient samples from James's Hospital from severe COVID patients, and you're trying to measure stuff in them. And other labs began to do this, and lo and behold, they find the same inflammatory factors in rheumatoid were up in COVID. And IL-6 is a good example, actually. And there's a drug called tocilizumab, as you know, that's used to treat rheumatoid patients. Give it a go in COVID, and they began to see efficacy. So in other words, there was overlap. And it's not surprising because, the immune system is the same in arthritis as it is in COVID when it goes out of control. You see the same cells, the same cytokines being made. So they could redeploy then, amazingly. I mean, when you tell people this, they say, how can this be? A drug that you'd use to treat arthritis is working in COVID. It's simply because they're both inflammatory diseases. You can ramp down the inflammation. Another big one is baricitinib, which is approved for rheumatoid. That showed efficacy in COVID as well. And all you're doing there is putting the fire out, in this case in the lungs. But equally, you can put the fire out in joints and see a therapeutic effect there as well. So in other words, it became obvious in a sense that you could target the same process in COVID as you could in something like arthritis. And then the trials showed benefit. So it's tremendous.
And if I shift now, towards obviously your research into the area of arthritis, many people listening to this will be living with arthritis. Certainly the last, if you like, 20 or so years, 25 years, have seen huge developments in the area, particularly for inflammatory arthritis. But you've worked on some of that as well. So can you tell us a bit more about that?
Well, I can go back a long way, to be honest. So rheumatoid arthritis was the big one when I was a young student because it was so common. And when I began my PhD, Gráinne, there were almost no therapies at all. It was an unrelentingly difficult disease which involved people getting huge disability. And they would give them various things like non-steroidal anti-inflammatories, and they would get rid of some of the symptoms. They gave them steroids, of course. They would get gold was even used, gold compounds. And these showed some effects, but they needed new ways to approach this. And I was lucky to work in the UK with key labs who worked on TNF. That became the big thing. And a guy called Mark Fellman, who I knew very well, he showed TNF in rheumatoid. My boss in Cambridge was the first person to show TNF could cause joint destruction. Can you believe it? That was 1986. And I went to work with him at the time, and we were amazed. Here was a molecule in the immune system causing joint destruction. And of course, then the clue was there, let's block it. And all the anti-TNF therapies flowed out of those discoveries. And I'd worked on TNF in the 80s. So now many of us did, but we worked on those very important inflammatory pathways. And so I was always close to it and working on it in various ways. And my work got more and more fundamental in the end, right? Could we really get the initiation of these diseases? And we moved into the kind of early part of rheumatoid and things like toll-like receptors. There's various components that we worked on for a while, and that led me into a whole new area in my lab. A thing called NLRP3. We'll hear this. This is the key switch for the immune system. That's in things like osteoarthritis. It's in gout, and we discovered a drug to block it. So my work was always trying to get new therapies ultimately to deploy in these diseases, you see. So I've always been very close to rheumatoid over the years because it's still the commonest of all the inflammatory diseases, especially osteo. And as you know, there's almost no ways to stop osteo.
I was going to ask you about that because I suppose sometimes when you talk to people with arthritis, those that have been living with inflammatory have seen huge developments and, therapies be developed that really have life-changing impacts in terms of a positive impact on quality of life. But there hasn't been that sort of shift or shifting of the gears towards the development of therapies for osteoarthritis.
Yeah.
Is there anything on the horizon there that might give people hope?
What happened was rheumatoid involves the immune system for definite. And once we knew that it was an autoimmune disease, you could then really study it closely, develop therapies to stop the autoimmunity. And that's what came out of this, and the anti-cytokine therapies, or even the B cell, like Rituxan. They were all developed because rheumatoid involves autoimmunity. Osteo is always different. There isn't much of an immune component. you don't see B cells. It's joint destruction, cartilage gets eaten away, and that was more difficult to get at then, you know. And they tried to develop ways to stop the cartilage being destroyed. Those drugs had side effects, didn't make it, you know. The big thing in osteo is pain. And there's a massive need for much more effective ways to manage the pain of osteoarthritis. Again, we're seeing a bit of progress there. And as we just discussed, like many charities are focusing on pain as the key thing to go after, because I think a survey was done in the UK among arthritis patients, and the number one thing they said was pain and fatigue. They were the two biggest symptoms. So again, we're seeing a bit of progress, but it's a strange one. It's been slow. And wouldn't it be wonderful if we could stop osteoarthritis in its tracks or promote repair? That'd be the real holy grail there. And stem cell therapies being looked at to build back the collagen, you know. So it's a very active area of research. We need a breakthrough in osteoarthritis like we got with the anti-TNFs in rheumatoid. That'll be tremendous. And it will come. It'll just take a bit more time and effort, I guess.
And I suppose if you look to the future, what are you looking forward to in terms of, what is there to look forward to in terms of like what's happening in the world of inflammation and immunology as we move into this century?
Well, research never sleeps. Let's put it that way.
Yeah.
I mean, it's amazing the amount of research that's still happening in inflammatory diseases, including rheumatoid. That people see, remember, some patients don't respond. Some stop responding to the therapies. So there's still a big, what we call an unmet need in rheumatoid. And the drugs at the moment slow it down, but they don't cure it, you know. So it would be tremendous if we could figure out what's the trigger for this disease. Now, that's a really difficult thing to do you
think we're closer to understanding what that trigger is?
No, that's a tough one.
So many factors, aren't there?
Too many factors. And it's probably multifactorial, you know. It could be an infection. You never know. One famous one is Lyme disease can turn into rheumatoid. So that tells us something. That's caused by bacteria. So we'd love to get more on that. And there hasn't been a huge amount of progress there, really, you know. So certainly more work on the origins of these diseases would be great, especially in pediatric arthritis, for example. What's triggering that in children would be brilliant to get more insights into that, you see. And then as we just discussed, osteo was the big one because there's been no real advances there, you see. So again, I think what's happening now is new sort of technologies have been invented to study any disease. Genomics and all these fancy techniques are there. They should begin to yield new clues, you see. And really what it's about is discovering what's going wrong in the body and then developing therapies either to stop it going wrong or to treat it when it starts to go wrong. That's every disease, really. So again, it's heading in that direction all the time. And it's not for want of trying. I mean, many labs all around the world are still doing their best to study these diseases and understand them. You know, like one big breakthrough in the last, say, 18 months is in rheumatoid in particular, they've even found new cell types or subtypes of cells that are brand new discoveries. Isn't that fantastic? So we're learning more all the time, and that learning should ultimately give rise to new therapies is the idea.
So the area of immunology in Ireland, like we perform hugely on a world stage. Why do you think that is?
That's another good question. I think it's partly because we punch above our weight in the sense that there's lots of really good labs. Okay, so the proportion of really good labs is higher than other countries, if you know what I mean. And often these metrics are based on the impact of your publications, say, on average kind of thing, you know. So if you've got slightly better players on the team, even though we haven't got scale. I mean, there's more immunologists in Harvard than all of Ireland. Let's put that bit out there. But the immunologists we have here are very good. I mean, there's fantastic immunology happening, you know. There's many good labs basically making discoveries. So in these league tables, we do very well as a result. I think it's partly because we had investment from the government, Science Foundation Ireland supported many labs. You need money, you know. Once you begin to see success, of course, that can breed more success because you attract people in. And it became a process over the years that grew and grew, I suppose. And now, as you say, I mean, there's probably 10, 15 world-beating labs in Ireland in immunology, which is tremendous, isn't it? And they're all working on different aspects. Some are doing vaccines, some are doing cancer even, you know, and some are doing rheumatoid and the diseases we're talking about. So it's a great testament in terms of, support over the years to the system, I suppose. So
the area you work in research, I mean, it's a long game, you know. How do you stay motivated? Because I'm sure you've highlighted some of the great successes there, but I'm sure there have been times when, you know, it's been hugely disappointing as well.
Your heart.
So tell me about that. How do you deal with that and kind of move forward? Because you're obviously you're leading a team of people as well in this area.
Yeah, little pleasures as you go along. You know, you can't expect to find a cure for disease. That's far too unlikely, you know. So little baby steps help you, you know. And if you make a small discovery, that gives everybody a lift, you know. So I think you've got to stay focused on the big picture. which would be, in my lab's case, to understand these diseases in as much detail as we can and maybe discover new aspects to them. And then, secondly, the notion then that you might actually get a therapy out of it would be brilliant, you know. But then remember, like a PhD student in my lab might make a discovery. It's not the best discovery ever, but it's very sound, very solid. It's rewarding scientifically, you see, and that keeps you going. So never forget, every publication makes some kind of contribution. There are tens of thousands of papers coming out on rheumatoid arthritis every year. They're all little bricks in the wall kind of thing, you know. So every little bit counts, really. That gives you satisfaction.
And if I was to ask you about, you know, one success that you can particularly recall over your career so far, what would it be? What would the one that you would?
Well, the biggest one for us, without doubt, has been this thing called NLRP3, which was discovered by a Swiss lab actually initially. A guy called Jörg Chopp in Lausanne discovered it, and it's a key on switch in inflammation. And he discovered it 20 years ago actually. And it became very clear NLRP3 was in the middle of all these diseases. Now, in the case of arthritis, it is things like osteo. It's gout, you know, more important than in rheumatoid, for example. So it's a subset, if you like. Another one, Still's disease, is another one that it's in that family disease. NLRP3 is really important, but it's also in Alzheimer's and Parkinson's and COPD in the lungs. It's a universal pathway for inflammation, and guess what? It's in COVID as well. There's evidence of it overactive, so it becomes overactive, and we found a drug to block it in 2015. We, by luck in many ways, came across a drug that could block NLRP3, which had been developed by Pfizer for rheumatoid arthritis. Isn't it interesting? And didn't really work in rheumatoid, and they shelved it. We've seen that, and we began working on it, and then lo and behold, this became the start of a big program that gave rise to 2 drugs based on that NLRP3 inhibitor, which we now gave to Roche. They're now developing it. They're running trials as we speak with the drugs that began in my lab. Now, the hope is they may have therapeutic benefits in a range of diseases, you see. So I'm waiting now, as ever you're waiting in science, we're waiting to hear back on those drugs. And for me, it was a thrill because my whole team, huge contribution. Rebecca Kolb was a student. I mean, she was on first author on Nature Medicine paper. That was a great achievement. Did a fantastic job, you know. We had a guy called Seth Masters in Australia who'd been in my lab helping us. So it was a big team effort. To see that come to fruition in that way is great. Now, we're not there yet. We're waiting now for the clinical data to come back from Roche to see if it's working or not, you know. So I'm keeping my fingers crossed. But if that works, it'll be great. The second one I would mention, though, is beginning in 2013, we discovered that in inflammation, including in rheumatoid, you get a very strange metabolic imbalance. So the way the rheumatoid joint uses nutrients is weird, basically, right? And you get offshoots, you get funny byproducts being made. That's a very exciting area. It's called immunometabolism. And my lab now is obsessed with that. And to make it relevant to rheumatoid, one of the metabolites we found is anti-inflammatory. It can turn inflammation off. Guess what? In rheumatoid, that goes down. And the more severe disease, the less of this there is. Now, of course, then we think, could you use that now? Could we give rheumatoid patients a supplement to boost that, to restore it? And my company Citrix in Oxford, they're developing mimics of this to see if that, and that's very early days. But that was a new idea that you wouldn't think rheumatoid is a metabolic imbalance. But there's evidence for that, you see. So again, that's a very exciting prospect. We could end up with a way.
So we're just learning more and more about this.
Oh, the time. What keeps, by the way, in answer to your previous question, what keeps you going is new discoveries. Excite you. You know, that's fascinating. Let's go after that. You know, and that was an example of that, really. So they're the ones I'd highlight at the moment.
And obviously, you're here today, and it's clear that one of your passions is this whole area of science communication. You've written several books. I suppose what inspired you to write? Because that's a...
Yeah, well, I was always a teacher, remember, in university. I got a job in academia to give lectures, and I quite enjoy that a lot, you know. And then I was asked on the radio, just on Newstalk a couple of times, and then a publisher heard me on the radio, Gill, and they said to me, do you want to do a book based on your radio stuff? And I said, no, I'm too busy for that. I couldn't possibly write a book. But then I began writing, and I quite liked it, you know. And that book came out, and then said, this is quite good. I like this now, you know. So it was kind of a stepwise process, you see. And they keep asking me back, Gráinne, that must be good, you know. In other words, they'd be ditching me pretty fast. And there's a real thrill in explaining things. As I say, I do it to students, so why not tell other people the same stuff? And my friends would always slag me off, like in the pub, I'd be there explaining my research to them using like beer bottles and beer mats to explain the immune system, and I got a thrill out of that, you know. So I think maybe I've always been a teacher, and it comes out of that really.
So you wrote a children's book as well. I know it's on my shelf at home.
Yeah, Gil asked me to do that. They said, do you fancy doing a children's book? I said, why not?
Yeah.
And that was a thrill because they got a great artist to do all the drawings and everything, and that was a really joyous thing to get involved in too. So you never know. And again, it's about trying to inspire them really and say, look, science is great. It could be a great career. The more people we can get doing research, the better, remember. Because they might make the key discovery for diseases in our case, or any branch of science really, you know. So that's part of the motivation to try
it's about making science accessible
exactly,
to people.
To turn people onto science really is what it's about.
And lastly, maybe just back to the pandemic. Do you think we'll eventually get out of this?
Absolutely. Oh yeah, as you know, I've always said that from the very start. Well, I mean, we have to get out of it, don't we? And all that science that's happened, can you imagine the last 18 months? A vast amount of effort. And it's culminated in the vaccines and these new therapies, or repurposing of therapies, as we just discussed, you know, and they're working. I mean, so what's happening now is you can envisage a future where COVID-19 will be in the medical textbooks, and there'll be a chapter on infectious diseases, and it'll list them all. And COVID-19, preventable with vaccines and treatable in hospital, and that's where we're headed. Now, when are we going to get there? It'll burn around for a while. It'll become endemic, as we say. There'll still be little outbreaks here and there, you know. There's still a risk of new variants, but we can now develop vaccines against those anyway, you see. So in other words, it's not this massive unknown that it was at the start when we're all terrified and what's going to happen. We've got great prospects really to get this on the run really, and it's just a matter of when. It was never a matter of if, actually. I knew science would get there in the end, and there's been tremendous progress over the past 18 months, as we've seen.
I suppose particularly in the developed world, you know, we can see in terms of Ireland, in terms of our vaccination rates, it's right up there, and in other developed countries. But do you see the low implementation of vaccines in the developing world? You know, having
that's a tragedy. I mean, the worry we have is this: it'll become like TB and malaria, afflicting the poorer countries forever. Remember, TB kills 3 million people a year, for crying out loud, in developing countries. Malaria, terrible. So it could become like that. Now, we don't want that. The goal at the moment is to get the vaccine into these countries as quick as we can, and then we can potentially eliminate it. And there's a massive motivation, of course, to do that. And maybe we'll see better approaches to other infectious diseases on the back of COVID, which would be tremendous, because these diseases are still devastating to many countries, you know. So I think we may see good things come out of COVID that go beyond COVID, and let's hope that happens, that we will learn from this in many ways, you see. But you're right, though, the number one concern we have now, actually, is new variants emerging. They will emerge in developing countries because it's dividing all, you know, it's rampant. We've got to get the vaccine into those countries to stop those new variants, as well as because people are suffering. I mean, there's kind of two reasons. There's an ethical reason, and then there's our own reason, you know. And both of those are so important to get the vaccine into developing countries. It's really important.
Luke, thank you very much for coming in. It's been great talking to you.
Thanks, Gráinne.
That's all from this episode of Inflammation Nation. Don't forget to subscribe on Apple Podcasts, Spotify, or wherever you get your podcasts. For further information about arthritis, you can visit our website, arthritisireland.ie, or contact our helpline on 0818 252 846. See you next time. Inflammation Nation is supported by Pfizer.